welcome all of you on behalf of GTU for this active learning video lecture communication series. Today, myself Sachin Sharma. I am currently working as an assistant professor at SVBT Gandhinagar College, and I am pursuing my PhD from GTU. Okay, so today we are going to see all about batteries. Topics that I am going to cover in this battery series is introduction to batteries, definition of batteries, like then characteristics of batteries, operations, how to operate batteries, different types of batteries, primary batteries and secondary batteries, the capacity and discharging of batteries, how to extend life of batteries and life of batteries, then homemade cells or batteries, and what is the best battery, application of batteries, and at the last I will show demo of how to make a homemade battery. Okay, all of us know about battery, right? We all have heard about batteries. So batteries come in all shapes and sizes, and there can be as many as there are species of dog, right? Rather than giving batteries unique names as we do with our pets, we distinguish batteries by their chemistry, voltage, then size, capacity, specific power, how much they can deliver, and there are many other parameters, right? A battery can operate as a single cell to power a cellular phone or mobile phone, or it can be connected in series to deliver several hundreds of volts to serve a UPS, that is uninterruptible power supply system. When our light goes off, when our AC is not there, at that time we use UPS, and again the electric powertrain of a vehicle. Some batteries have high capacity but cannot deliver much power, while a starter battery, if you see, has a relatively low capacity, but even then it can crank the engine with 300 amperes, right? Okay. The largest battery systems are used for grid storage to store and deliver energy derived from renewable power sources such as wind turbines and solar systems. If somebody is having a wind farm, you might be aware that a 30 megawatt wind farm uses a storage battery of almost about 15 megawatts. What this shows is the importance of batteries, how batteries have generated, how batteries have gained the importance, and what is the importance of batteries and different applications of batteries, right? Okay, so by definition, a battery in electricity, it is a device consists of one or more electrochemical cells that converts stored chemical energy into electrical energy. Okay, so what do you mean by electrochemical cell? Electrochemical cell, it is a device capable of either deriving electrical energy from chemical reactions or helping chemical reactions to the introduction of electrical energy. Common example we can see of an electrochemical cell is a standard 1.5 volt battery. Okay. So this is like picture of battery. The left side and the top you can see the electrical symbol of battery. It is a polarity, it is shown actually plus minus, and if you see two cells are connected, right? So it is a battery. And if you see at the right side of the top, proceeding from the first one, it shows a battery that is 4.5 volts, that is its rating. Then we have next battery, then different cells are there. At the right side you can see that is a button cell also is there, and it shows also the size and the type of battery, right? At the end, if you see at the corner side, that is a Panasonic, it is written, it is a camcorder battery to record videos and all those things. So batteries come in all shapes and sizes, right? So how to characterize batteries? So when you are going to buy a battery, what you should look while buying a battery? First of all, the chemistry. The most important or common chemistries are the lead, nickel and lithium. Each system requires its own charging algorithm. Again, unless provisions are made to change the charge setting, different battery chemistries cannot be interchanged in the same charger. Also, while shipping or while disposing of batteries, you should look the chemistry and observe different regulatory requirements are there. You can't, if the battery has discharged or it is disposed, you can't directly throw that battery in the dustbin. You have to see, it can be hazardous also, it can be poisonous also, right? So those requirements you have to see. Next is the voltage. Whatever the voltage it is written or imprinted on the battery, it refers to as the nominal battery voltage. Again, we have to observe the correct voltage when connecting to a load or a charger. Do not proceed if the voltage differs. Now, what do you mean by open circuit voltage and closed circuit voltage? Open circuit voltage on a fully charged battery can be slightly higher than the normal, right? If a battery has written, it is imprinted on the battery 9 volts, doesn't mean that it will be 9 volts. When you buy a battery, you have to measure it with the help of digital multimeter or analog multimeter. It will somewhat higher, right, than the voltage that is imprinted on it. Closed circuit voltage represents the battery voltage under load or on charge, and the readings will vary accordingly. Okay, third is the important parameter or characteristic of battery. It includes capacity. Capacity represents the specific energy in ampere hours. Manufacturers often overrate a battery by giving a higher ampere hour rating than it can provide. We can use a battery with different ampere hour, but we have to make sure that we are using a correct voltage, provided the rating is high enough. Chargers have some tolerance to batteries with different ampere ratings. A larger battery will take longer to charge than a smaller one. You might have seen this thing. Okay, next important parameter is cold cranking amps. Okay, it is, in short, it is written as CCA. CCA specifies the ability to draw high load current. It is almost at minus 18 degrees Celsius, 0 degree Fahrenheit on starter batteries. Different norms are there and they specify dissimilar load durations and end voltages. Next parameter is specific power. Specific power or gravimetric power is density, indicates loading capability or the amount of current that the battery can provide. Always check this parameter because it is very important. A battery can provide a voltage, but you have to check current also, how much it is providing. Specific energy and energy density. Okay, what do you mean by specific energy? Specific energy or gravimetric energy density defines the battery capacity in weight. Energy density or volumetric density is given in size. A battery can have a high energy, specific energy, but a poor specific power, that is a load capability, as is the case in alkaline battery. Alternately, a battery can have low specific energy but can deliver high specific power, as is possible with super capacitors, right? Specific energy is synonymous with battery capacity and runtime. Okay, next parameter is C rates. C rates specify charge and discharge currents. How much battery, in how much time battery charges and how much time it takes to discharge. Those things we can get the information from this parameter. If it is written at 1 coulomb, the battery charges and discharges at a current that is par with marked ampere rating. So at 0.5 coulomb the current is half, and at 0.1 coulomb it is 1/10. On charge, 1 coulomb charges a good battery in about 1 hour, and 0.5 coulomb will take almost 2 hours, and 0.1 coulomb it will take almost 10 to 14 hours. So this is an important parameter. Okay, load. A load normally draws energy from the battery. Internal battery resistance and depleting state of charge causes the voltage to drop. Physical work over time is energy measured in watt hours. So whenever you are connecting a battery and there is any load, it will obviously draw some energy from the battery. Next important parameter is watts and volt amperes. Power drawn from battery, it is expressed in watts or volt amperes. Basically, watt is the real power that is being metered, that you can measure. Volt ampere is the apparent power that determines the wire sizing and the circuit breakers that you are using in the battery. On a purely resistive load, watt and VA readings almost will be same. It is all alike. A reactive load such as an inductive motor or fluorescent light causes a drop in the power factor from the ideal one, that is 1, it will drop to 0.7 or even lower. For example, a power factor of 0.7 has a power efficiency of 70. So power factor indirectly relates to a power efficiency, right? Okay, now how battery operates, right? So we are going to look about operation of batteries. So if you see this diagram, this is actually a demonstration purpose. This is a voltage cell. If you see, there are two half cells, right and the left, that red and the grayish color. The two half cells are there. They are linked by a salt bridge separator, which helps in permitting the transfer of ions but not water molecules, right? So battery, battery is a device that converts chemical energy directly to electrical energy. It consists of a number of voltage cells. Each voltage cells consists of two half cells connected in series, like you can see here, two half cells, they are connected in series by a conductive electrolyte containing anions and cations. One half cell includes electrolyte and electrode to which negatively charged ions, anions are the negative charged ions, migrate, that is the anode or the negative electrode, and the other half cell includes electrolyte and the electrode to which cations are the positively charged ions, they migrate, that is the cathode or the positive electrode. Okay, so when everything is connected in the redox reaction that powers the battery, cations are reduced, that is electrons are added at the cathode, while anions are oxidized, that is electrons are removed at the anode, because they attract each other, right? The electrodes do not touch each other but are electrically connected by the electrolyte. So if you see the tub, there are two tubs and there are two electrodes, that pink one and the grayish one, and if you see in the tub there is some liquid is there, right? So that is an electrolyte. The electrodes do not touch each other but are electrically connected by the electrolytes. You can have same electrolyte or you can have two different electrolytes also. some cells uses two half cells with different electrolytes also. A separator, that is, if you see, that is a salt bridge separator is there, that pipe size shape. A separator between half cells allows ions to flow, but it prevents mixing of the electrolytes. So if you have two different electrolytes, it won't allow mixing of those electrolytes. Again, each half cell has an electromotive force, that is again you can denote it by EMF, determined by its ability to drive electric current from the interior to the exterior of the cell. And then the net EMF of the cell is the difference between this between the EMF of these two cells, half cells, and it was first recognized by a scientist, that is known as whose name is Volta. Therefore, if the electrodes, by example, if the electrodes have EMFs E1 and E2, that those two half cells, if they have EMFs of E1 and E2, then net EMF will be E2 minus E1, or in other words, the net EMF will be the difference between the reduction potentials of the half reactions. So the electric driving force, that is denoted by delta V battery, or across the terminals of a cell, it is known as the terminal voltage or the difference voltage, and again it is measured in volts. So what do you mean by terminal voltage? A terminal voltage of a cell that is neither charging nor discharging is again known as the open circuit voltage, and again equals the EMF of the cell. So this is an important voltage, and you should know about this terminal voltage. Because of the internal resistance, the terminal voltage of a cell that is discharging, it is smaller in magnitude than the open circuit voltage, and the terminal voltage of a cell that is charging exceeds the open circuit voltage. And if you see an idle cell, if an idle cell is there, it has a negligible internal resistance, so it will maintain a constant terminal voltage of EMF E until exhausted, then again it will drop to 0. If such a cell, if an idle cell has maintained a 1.5 volts and stored a charge of 1 coulomb, then how much work we can carry out from that battery? We can carry on one complete discharge, it will perform a 1.5 joules of work. In actual cells, that is not an idle cell, the internal resistance increases under discharge, and the open circuit voltage also decreases under discharge. So if the voltage and resistance, they are plotted against time, the resulting graphs will typically be a curve. The shape of the curve varies according to the chemistry, again the internal arrangement that we are using. So this is how a battery operates. Okay, now types of batteries. We have different types of batteries. Basically we can categorize batteries in two types, primaries and secondaries. Again in primaries we have different batteries, again in secondaries we have different batteries. So what do you mean by primary battery? Primary batteries, irreversibly within the limits of practicality, they transform chemical energy to electrical energy. Again, when the initial supply of reactants, that is not there, that is exhausted, energy cannot be readily restored to the battery by electric means they are disposable batteries. Once used, you can't reuse those batteries. Disposable batteries are intended to be used once and it is discarded. Again, where these primary batteries are used, these are most commonly used in portable devices that have low current drain. Again, or you are used well away from, when you are quite away from an alternative power source is not there. In such cases, you are using primary batteries. Examples are like in alarms, in communication circuits, where electric power is only intermittently available. Common types of disposable batteries again include zinc carbon batteries and alkaline batteries. Alkaline batteries are quite famous, right? Okay, so now what is secondary battery or secondary batteries? When we are using the term batteries when we have more than one battery, right? Secondary batteries can be recharged, that is they can have their chemical reactions reversed by supplying electrical energy to the cell, restoring their original composition. The oldest form of rechargeable battery is lead acid battery, that is the oldest one. A common form of where this lead acid batteries can be used or they are used, a common form of lead acid battery is the modern car batteries, which can in general deliver peak current of 450 amperes. So if you see a car, it undergoes in various changes, like it will have shocks, vibrations. So in those conditions we need a battery which can exist, which can be a durable, which can be reliable. So lead acid battery, it is used in modern car systems. Now other portable rechargeable batteries include several dry cell types. Again in secondary batteries we do have two types of cells actually. One is dry cell, the second is the wet cell. Dry cell means that electrolyte it is in pasted form, right? Whereas in the wet cell the electrolyte is in liquid form. So other portable rechargeable batteries include several dry cell types, which are sealed units. They are sealed in a package and they are therefore used in appliances such as mobile phones. We all have actually mobile phones, laptop computers. So in those laptop computers and mobile phones we use actually these dry cells, or you can say is a rechargeable cells. Cells of this type in order of increasing power, density and cost include nickel cadmium, that is again one famous type, nickel zinc, nickel metal hydride and lithium ion cells. By far, if you see the comparison, lithium ion has the highest share of the dry cell rechargeable market. Meanwhile, there are other batteries, other cells also, like nickel metal hydride has replaced nickel cadmium in most applications. Reason is it is having a high capacity, but again Ni nickel cadmium remains in use in power tools. Power tools means for cutting diamonds and all those things, two-way radios and medical equipments. Nickel zinc, it is a new technology that is not yet well established commercially. Experiments are going on, researches are going on. Okay, so now next topic is capacity and discharging of batteries. What is the capacity of batteries? Because that is quite important. When we buy a battery, how long it will take, how long it will work properly, efficiently, then again when it will discharge, how much time it will take to discharge, and then again at what time, after some time, after what time we have to recharge it. So battery's capacity is the amount of electric charge it can store. If you have more electrolyte and the electrode material, if it is there in the cell, it will have a greater capacity, right? A small cell has a less capacity than a larger cell with the same chemistry, and they develop the same open circuit voltage. A small cell we can use in mobile phones or toys, right? Whereas in if larger cells, they are used in industries. Because of the chemical reactions within the cells, the capacity of battery, it again depends on the discharge conditions such as the magnitude of the current, again which can vary with time, the allowable terminal voltage of the battery, that is when we buy a battery and we measure it in a multimeter, that is the terminal voltage across its terminals, plus and minus polarity is there, allowable terminal voltage of the battery, again temperature and other factors. Available capacity of a battery again depends upon the rate at which it is discharged. So how fast it is discharging, that is also an important parameter which helps in calculating the capacity of a battery. If a battery has discharged at a relatively high rate, the available capacity will be lower than expected. So if a battery is discharging at a very high rate, its efficiency will also be low. But again you should check that it is not discharging too slow also, because if it is discharging too slow, then it can't be, we can't use that battery, right? It will automatically self discharge. So how to make a relationship? There is a one famous law,